Okay, so here are the solutions for the two questions I posted for 3.4. Number 1 asks you to find a vector equivalent to three different differences of vectors. So the first one is asking you to subtract vector AD and CD. So first of all, let's start by finding vector AD. Drawn head to tail, we know that AD is going to look like this along the top. And I want to subtract vector CD. So vector CD is also going to point up in that direction. But here's the rule. When you subtract vectors, you're going to add its opposite. So this is the same as stating vector AD plus vector DC. Right, you're adding the opposite vector. So notice how I changed the direction of CD. So I'm going to show that using a different color. So if I'm adding DC, then I'm really going to add that vector there. So now let's look at what we have. AD and DC, right? We're adding the opposite. That's the same as subtracting. Well, what's our resultant vector? I'll draw the resultant in green, and that's going to extend from A down to C. So the answer is AC. All right, so that's number 1. The second one, I wanted you to do EC minus CE. So I'll get you started there. We know that vector EC is pointing this way, and I want you to subtract CE. Well, CE is just the same vector in the opposite direction, which is there. So I'll do it down here. EC minus CE is the same thing as writing EC plus the opposite vector, which is EC. Well, look at this. We have a vector added onto itself. So EC plus EC, well, we have two vectors that are added of the same magnitude. We just double that length. So what's a vector that is the same as twice EC? Well, that's the same magnitude as AC, right? And for the last one, we have BC plus CD. I'm going to have you do this one on your own. I'll post the answer, but here's a little hint to start. I want you to start with the first two and then subtract vector AD. So find this one first, find what those two add up to, and then subtract AD and check back on the page for the answer.